Hello everyone, we are now in the sixth lesson in the module 4. The sixth lesson is about piecewise and step functions. So let's see what these both mean. The learning objectives are identifying and graphing piecewise defined functions, and identify and graphing step functions. These are the two objectives which we'll cover in this video. And the keywords are piecewise defined function, piecewise linear function, step function, greatest integer function. Now, many of these words might sound new or different. Don't worry, all of this will be explained in this video. Now, first of all, piecewise defined function. What is this? As you can see, piece means a certain piece. It's defined in different pieces. What if I have a graph like this and then another graph like this? This can be piecewise. Okay, this won't be the exact graph, but for you it's mainly linear. So what if a graph is like this and like this and like this? These are all piecewise. See, from year to year there is one graph function, and then it changes from year to year, and then it again changes from year to year. These are pieces of graph with different functions. Because we're dealing with linear, it's all straight. But if it's non-linear, which you might study in the future, say it might be linear, a quadratic, or a cubic, and it might be different functions. Okay, so here you need to understand piecewise linear function as graph composed of some number of linear pieces. In the sense, now look at this. Let's just look at the answer for a minute. Here, this one, look over here. There is one graph from -4 to +1. It is following this pattern, and then after 1 you can see, not from -4, sorry, it goes from it goes till -infinity. You can see the best way to see is this 1. Can you see this 1 over here? Before this the graph is entirely different, and after this it's entirely different. So this is what a piecewise function means. You have two separate functions, but the domain is different for both. Now let's see how to graph such functions. It's very simple. The question will be like this. You can see this is a piecewise. Why? Because there are two functions, two equations given, and the domain is different. One domain is when it's less than or equal to 1. One more is greater than 1. Now what do you do? The best and the easy way, if you understand the graph directly, you can graph it. Or what you can do is you can easily make the table of values over here. See, the table of values is there, right? Let's create for the first graph now. Please note, can you see this? X is less than or equal to 1. That means the values can be equal to 1, but it must be less than that. Then it can be 0, -1, -2. It can't be 2 or 1.5. It can't be more than 1. That is what it means. So now we will take some values less than 1, 1 and less than 1. So 1, 0, -1, and so on. Now what about the y values? Here you just need to put this x value in this equation. Here instead of 2x you have 2 times 1 plus 4. So 2 times 1 is 2 plus 4 is 6. Same way, put 0 here. It becomes 0 plus 4, 4. Now what about negative numbers? It will be 2 times -1 plus 4. It's -2 plus 4, 2. Whereas if you substitute 2 times -2 plus 4, it will be -4 plus 4, 0, and so on. Easily you can find it. Now you can start plotting these points. You can plot any 2 points directly and then join them. Say for example 1 and 6. Where is 1? Y is 1, 2, 3, 4, 5, 6. This is 1 point. And 0 and 4, 0 and 4. And now just draw a straight line. This is possible. Otherwise, if you're thinking of how to graph it directly, you can see the y-intercept. We have gone through this before. Y equals mx plus b. What is the b value? The y-intercept value, it's 4. So 0 and 4 is 1 point. Now it's 2 here. That means this 2 means it is dy by dx, that is equal to 2 divided by 1. All positive. So from here, what is the x value? It is 1 x value, positive 1. What is y value? It's 2 upside 1, 2. So this is how we get the second point, and then draw the straight line. So there are various ways to graph this. So this is the answer for the first graph. But it is not over because there is one more part of the graph, right? Here, so you need to do the same thing, but make sure you start with this point, but more than 1, not less than 1. So you start 1, 2, 3, 4, 5. But you're not supposed to include this one value. I will tell you in a minute what we need to do. See here, this one, it is properly done, a straight line, nothing is there, even 1 is included. But now here, if you look carefully, it's greater than 1. That means 1 should not be included, right? But when we do the table, include 1, and now let's see what is happening. Here, we need to plot these points in the graph. Say, for example, 1 and 2. Where is 1 and 2? 1 and 2, it's over here. And 2 and 1 is over here. Any 2 points are enough, and draw a straight line. Okay? Now, there is a catch. See here, whenever you see values like this, less than 1, greater than 1, there is not equal to sign. This means greater than or equal to, less than or equal to. Here it is only less than or greater than. In such cases, you must keep it in mind that you cannot directly, draw a straight line. You must have a hole here. What does this hole mean? The hole symbolizes that it is not equal to 1. This 1 does not belong to it. Whereas all the values other than 1, greater than 1, belongs. Is that clear? In case if this was x less than 1 and this was x greater than or equal to 1, then this would be a point. It wouldn't be a hole. Here it would have been an empty hole. There should not be any markings. It should be a hole. So this is a hole for greater than or less than. This is a point. It must be filled, okay? For less than or equal to, greater than or equal to. This is the way we solve it. And now you can just get these points and start plotting. You got the line. Now don't directly do this method over here. If you are doing, the direct method, where is the intercept? 3. That means over here 1, 2, 3. This is 1 point. And then we need to take minus 1 by 1. So 1 down, 1 right. And this is the point you get. You can draw a straight line like this, but make sure you understand the values only start from 1. So when you're drawing, put a hole over here and then extend the line. That's it. So this is how you graph. And this graph, whatever we got, is piecewise function. So this is it. And now over here, there are a few things you must remember. You do not need to write all this. You do not need to write all this. You can directly see the first part of the function is less than or equal to 1. So at 1, wherever that graph is there, you should have a point and then extend it down. At this point, there must be a hole and then extend the graph. Now, there is one more thing which you must carefully look into. That is the domain. What is the domain? Domain doesn't stop here. See, domain is all x values, right? Don't think, okay, should I write minus infinity to 1 and then 1 to infinity? No. Can you see over here, 1 is included in this graph. So you must make sure you write all real numbers. It's from minus infinity to positive infinity, or you can just write all real numbers. This is the answer. But now, look at the graph. Is there any part of the graph going above this point, above 6? Is it any part? It is not going above that value. See, above this, yes, we have graph. This part of the graph is there. But above 6, there is no value. So the range is all values less than 6. So y is less than 6. But you can see this is a hole. This is not a hole. This is a point. So we write less than or equal to. If at all this graph wasn't there, this was a hole over here, then you have to write y is less than 6. So these are the considerations you need to take. So here we have another similar problem. Please do try it by yourselves. Please try more and more problems. You will be more thorough and it will be easy for you. Now here, you can make the table of values. Let's look into the graph. I'll just explain it directly. What is this x value? Minus 2. So minus 2 is a very important point here. Now minus 2, right? What is happening? Here we have less than or equal to minus 2 for this equation. Minus x means it's going downwards. Now here, sorry, both will be going downwards, so that doesn't matter. First of all, minus x plus 1. How would you do is, you can just take table of values. Let me take less than, right? So let me take values as minus 2, minus 3. Only two values are enough. Let me substitute in this equation. Instead of my x, I'll put minus 2. Minus x is minus 2 plus 1, that is equal to plus 2 plus 1 is 3. And same thing over here, minus of minus 3 plus 1 is 4. Now let me plot these 2 points, minus 2 and 3. Where is minus 2 here? 1, 2, 3. 1 point here. And what about minus 3? It's 4, minus 3 and 4. And now you need to join these two lines, but make sure it goes backwards. Why? Because it is only possible for less than 2. So this is how we get it. And since you have less than or equal to, here it is a point, not a whole. Okay, this is a point. Now what about the other values, other equation? Same thing, but start with minus 2 and then go with minus 1 or 0. I'll take 0 because it's easy to calculate. I'll take these 2 points. Now minus 2, it's greater than minus 2. X is greater than. That means the graph will go right side. So you can see downwards. Now what you do? Substitute this minus 2 here. Minus 3 times minus 2 plus, sorry, it's minus 2. What is the answer? Minus 3 times minus 2 is positive 6. Minus 2 equals positive 4. Same thing with 0. It's minus 3 times 0 minus 2. That will become minus 2 only. Why? Because 0 minus 2 is minus 2. Now where minus 2 is there, you need to put positive 4. Minus 2, 1, 2, 3, 4. Now I'll put this over here, 1 point. And then 0 and minus 2. Can you see 0 minus 2 over here? Now look carefully. It is only greater than. So I have a whole here, not a point. See, can you see? Okay, that's very bad. Now you can see there is just a hole here. Okay, it's not a point. And at 0 and minus 2, you need to just join this like this. This is how you graph this. Very simple. You can just do it within like 2 minutes. Take two values for here, just look at which is the point. Okay, minus 2, it should go left and right. Now what is the domain? Domain, as we told, it's all real numbers. Okay, all real numbers. Real numbers means all the numbers. Now real numbers means everything, decimal, integers, fractions, all numbers which can be counted. Like, I mean, not counting numbers, it's like minus 10, minus million, minus infinity until there. Okay, all real numbers. Now this is fine, but what is the range? What is the y value? Look here, the graph is going downwards. Over here it's keep on going upwards. So range is also all real numbers. Why? Because this keeps on going towards plus infinity and here downwards to minus infinity. So both of this is all real numbers in this case. Only when this function, if it goes downwards like this instead of up, then it would have been less than or equal to, sorry, it will be less than, y is less than 4. But here it is not the case. Both are going in different ways, so it will be all real numbers. So this is how we graph it. So these are the two things which you must remember to graph. And now these are piecewise functions, and now we will go to step functions. Now what is step functions? As you can hear about it, it's something to do with steps, right? There is one important thing. One of the step function is the greatest integer function. Now what it means is, whenever you see these two dashes, you can write it like this. Okay, in here, see. Okay, that's, we just write two big brackets. Okay, I mean, I usually write it like this, x, and this is the two big brackets. This means it's a step function. Okay, now here there are various ways to write this, but whichever is comfortable, two dashes, that are two big brackets, is more than enough. Now the greatest integer function means, say I have a value of 2. Now 2, 1.5. Now if I have this equation, y equals step function of x, right? Now let me have value of 2, 1.5, 1.25, Then let me take 1 and 0.5. Okay. Now, if I put over here 2, which is the is 2 an integer? Yes. So if x value is 2, what is the y value? This is x values. I'm randomly choosing y value. Put this x over here. Y equals 2 itself. But now if I put 1, you must make sure that this will correspond to an integer. Now, which integer? It is the integer which you see over here. Now, say for example, you can see 1.5, right? Which is the integer before it. If it's 1.5, just see the number over here. This is equal to 1. This is the easy way to remember. If it's 2, it's just 2, it's just 2. But if you have 2.5, it would have been 2. Okay. Now I have 1.25. What happens to 1.25? The integer here is again 1. Now this 1 is 1. But now 0.5, what is the number? 0. So these would be the answers. It's a little bit different. You'll come to know when we solve problems. So just remember, when you put any x value, if it's a decimal point, if it's not an integer, integer is just whole numbers like 1, 2, 3, 4, minus 5, minus 6. These are integers. It can't be decimal, okay? Now, if you see a decimal number 3.25, then just put this 3. This is equal to 3 inside the step function. It depends on the conditions as well. We will see different types of problems. Now, you can see this is something like a step function. Now, I told you the values, right? Say, for example, we will consider 2.25. This is equal to what I told. It will be 2. So, let's see where is 2.25. 1, 2, 2.25 is somewhere here, right? Y value should be 2. See, all these values from 2 until 3, until 2.99, it goes over here. 3 will be here. Can you see the hole? 3 is this part. 2 is this part. Now, when you come to this 3 here down, it's a continuity, right? You should put a hole here. Why? Because 3 doesn't belong to 2. 3 belongs over here upside. So you just put a hole. So wherever hole, the above one must have a point. So this is how it continues. So we will see the problem now. Now here you can go through this. You have to graph function, step function, sorry, x plus 1. And we need to state its domain and range. So now what is the over here, it's not direct y equals x. The equation over here, inside equation, see what is inside equation. It's x plus 1, right? So let me take some values for x. Let me take, say, minus 1, minus 0.5, minus 0. You can take more values, but I'm just taking simple values. 0 is always neutral, so you don't need to write any sign to it. Plus or minus, it's just neutral, both. So what about this? It'll be 1. 1.25, 1.5 to 2.53. Now, when I substitute this x value here, what happens? This is 1. It'll be minus 1 plus 1, that is equal to 0. Now, 0 is an integer, so directly write it. Now, what about this? When I put this value over here, it'll be negative 0.5 plus 1, it'll be positive 0.5, isn't it? Positive 0.5. That means the whole number is 0 here. Okay? Why? Positive 0.5. When you substitute over here, it will be negative 0.5 plus 1. That's 0.5. What's the integer? 0. Now, what if you put 0 over there? If you put 0, then you're going to get 0 plus 1. It's 1. Directly write 1. What if you put 1? 1 plus 1, it's 2. Directly write. But now 1.25 would be 2.25. But don't write 2.25. You should write 2. Same thing. Add 1 here. 2.5. It will be 2. 2 plus 1 is 3. 2.5 plus 1 is 3.5. It will be 3, 4, and so on. So these are your values. Now if you graph them, see, these are the table of values. You can see them. The same thing what we got. Now say we have considered 0. 0 will become, when you add 1, it will be 1, and then you consider it to be 1. Whereas more than 0, what is more than 0? It's 1. See, 1 value is there. What happens to 1? When you add 1, it will be 2. 2 is a whole integer 2. Whereas 1.25 is considered, we have 1.25. So when you add, it will be 2.25. See, the whole number is 2, so we get 2. So these are the way. If you understand one way, it's more than enough. So if you understand what I have told you over here, then you can see that they are just telling you these are all grouped. All these terms, see 2, minus 1.75, minus 1.25, all grouped together. But remember the method which I told you, just look into the integers, right? It works only for positive numbers. If it is negative numbers, it's other way around, okay? See, if it's negative numbers, you must see the lesser number. But don't worry, if you just see some positive values, you can graph it. See, now we have these values, right? We will graph it, you will get the graph. If you get any 2 steps, that is more than enough, then you can easily graph the other steps by yourself. So now you can see over here, look at these values, negative 1, where is minus 1 over here? Minus 1 is 0, yes. So let me mark a point over here. Now minus 0.5 is over here, it's again 0. So here negative 1 is included in 0, so it's a whole, okay? But what if I take 0? 0 is not included in 0. Why? 0 is 1, so 0 and 1. You get a whole over here, a point over here, point over here. So draw this until this down over here, make a hole. Now draw this hole. If you know any 2, then you just know this is a point, hole. Point, hole. Hole will be empty. Point, hole. And same thing can be taken to the left side. Point, hole, point, hole, point, hole. So this is how we can easily graph the step functions. I know it looks complicated, but if you understand the gist of it, if you understand, now just take some values. X as 2, 2.5, 3, 3.5. This much is enough. Put it in the equation. You're just adding 1. So add 1 to 2, it will be 3. So 3 is a whole number, so y is 3. Now what if you add 2.5 and 1? It will be 3.5. Take the integer only, it's 3. 3 plus 1 is 4, it will be 4. 4.5 will be 4 itself. Now let's plot these. 2, where is 2? X is 2 here, and the answer is 3. This is the point. Now 2.5 and 3. 2.5 is over here, so you just draw a straight line. Whereas if you go to 3, it is not 3, it is 4 over here. So you got a point here. So this becomes a whole, and then you can do the same thing and continue. So this is how we usually graph the step functions. Now here you have a check problem. Please do it by yourselves. This is the same thing what we just now did. Very straightforward. Please do try it by yourselves. I hope you have tried. You can just look through the answers over here. It'll be the same thing. See, if you're getting confused with negative integers, it's fine. Just take positive values. What I would do is, I would take, since it's minus 2, I would take, say, 3, 3.5, 4, and 4.5. What happens? 3 minus 2 is how much? This is the x values, y are. 3 minus 2 is 1. 3.5 minus 2 is 1.5. That will become 1 itself. Sorry, not 1.1. 4 minus 2 is 2. 4.5 minus 2 is 2.5. That's 2 again. And you just have to graph. So where is 3? 1, 2, 3. What is the value? 1. So at 3 it is 1. 3.5 again it is 1. 4 it is 2. And 4.5 it is again 2. So then you can understand this, below this point will be a whole. And so on. You can just correspond it. If you do 2 to 3 steps, you know that's the continuation, right? So it's fine. This is it. This is how you graph these step functions. Or this also called as greatest integer function, because we are taking the greater integer. Now over here the greater integer, like whatever is there over here, and that's it. Now we have some real world problems on step functions. See, in the real world problem, it might change, it might vary depending on the situation. Now let's see the problem. A state requires a ratio of 1 lifeguard to 60 swimmers in a swimming pool. This means that 1 lifeguard can watch up to and including 60 swimmers. This is very, very important. Including means 1 lifeguard is 0 up to 60 means 0 to 60 means it will be x is less than or equal to 60 and greater than 0. So this is the function, okay, greater than or equal to. So less than or equal to, sorry. Make a table and draw the script that shows the number of lifeguard that must be on duty based on the number of swimmers. So swimmers in the pool are given as X. We must just see. See, understand one of it. If the number of swimmers is greater than 0, it must be greater than 0. X must be greater than 0. Bigger sign is facing X, so X is greater than 0. But the fewer than means less than or equal to 60. There is how much? One lifeguard. So what if it's more? See, this is the first equation. 0, X is greater than 0 but less than or equal to 60. It's one lifeguard. Next comparison would be, start with 60. Greater than 60, less than or equal to 60 times 60 times 2 is 120. There will be two lifeguards. For every 60 people, there must be one. Or if it's more than 60, if it's 65 people, there must be two lifeguards. So this is how it is. So you can see, as you keep increasing, the same thing, just put this number over here and add 60 over here, you're getting 2. And if you keep on doing that, 120 and 180. But look over here, X is less than or equal to 180 and greater than 123. And you can just make these values. Very, very straightforward. Now you have to graph this. Very, very simple. How do you graph? You have this. So let's see. Here, where is the less than or equal to symbol? See, in real world it changes. Now here you can see less than or equal to is at 60. So 0 to 60, right? At 60 it is 1. This is a point. Where is less than? It is a whole, right? We had studied that in the piecewise. So make sure at 60, 120 over here at right side, there is the points. Okay, this is the points. And left side, they are the holes. Why? Because that is the overlapping part. This is how we do it. And first one it's 1, the next one it's 2, 3, 4, and it goes on. So this is how we solve the problems. Now then, so the circle means when there is more than 60 or multiple of 60, another lifeguard is required. See, as you come to the circle, when you exceed this number, you need one extra lifeguard. So here you can understand in real world problems, when it's dealing with people, person, you can't have 1.5. You should have an integer, right? So that's why the step function is very important here. So the dot represents maximum, okay? This over here, maximum. And then it goes on to the next level. So the number of swimmers can be found in the pool, particular number of lifeguards on duty. See, how many number of swimmers are there? That many lifeguards shows at the left side. That is how we can solve it. Let's see this one. At Louisiana's pet boarding facility, it costs $35 per day to board a dog. Every fraction of the day is rounded up to the next day. Graph the function representing the situation to make a table. Here there is an important thing which you must understand. Every fraction of a day is rounded up to the next day. This says what happens every day is rounded up to the next day. That means that is the domain, x values, okay? So here every day. So x should be greater than 0, but it's less than or equal to 1. So until one day, how much is the charge per day? It is $35. But as you increase to take one more day, it will be 1 greater than 1 but less than or equal to 2 is 70. And this is how we can easily look at this condition given over here and solve it. So it will be 0, x is greater than 0, less than or equal to 1, 35. But it's greater than 1, less than or equal to 2, it's 70. And you can see this is how it goes on. Now graphing is very simple. Here, over here also, see where is the greater than or equal to? At 1, the right side, 2, it's the points. Left side is just greater than, so it is holes. So this is how we can easily graph. And that's okay. I forgot to tell you about the domain, right? I think so. Okay, in this it's not asked. In one of the questions it was asked, but let me just tell you what is the domain. Can you guys think of the domain? Take your time, just think about it. What is the domain and what is the range? If you look properly, the domain is all real numbers. You can see everywhere there is a point. See over here it's a hole, but below it is a point, or it can be other way around. Point over here, hole over here. So all the x values are included. Always for step function, the domain is all real numbers. That means it's from minus infinity to plus infinity. That is the domain. Okay. What about range? Step functions goes from minus infinity to plus infinity even on the y-axis. So do I just write all real numbers? Is this correct? All real numbers. NOS. So this is the domain but not the range. All integers is the range. Integers. Why? Because look over here, in the previous problem, it's the best example here. You're not taking 1.5. You can't have human beings as half or 1.5, 2.5. You can just have a integer number 1, 2, 3, 4. In this case, you can't have any values less than 0. So it would be 0 comma infinity. This, but all of this belongs to z. Z is integers. Okay, if you write z, or if you don't remember that, just write integers. Integers. Okay, but z is the short form for integers. Now in, say for example, here in the before function where we graphed, see this for example, this is just a function, right? Here domain is all real numbers. Domain is the x values, right? It's all real numbers. Okay, it's all real numbers. But what about the range? Range R, I will write, is all integers. All integer values. You can write all integer values. That is Z values. Or you can write all real numbers belonging to integers. You can write like this. I'll just erase this. Now, if this was written, you should just write belonging to Z. Okay, this is up to you. You can write, you should just tell that you know, you understand. There can't be any decimal points. It can't be any, fractions or decimal points in the y values. It's only whole numbers, I mean integers. So that is the answer. So that is how we basically do it. We have done this. Here just keep in mind, it can't be negative values, it's only positive values for human beings. It should be 1, 2, 3 and so on. Same thing over here. Cost, it can be from 0 till infinity, but must belong to integers. So the best way to write it, the easiest way, which I would prefer to write, is range 0 to infinity, because we are dealing with money or human beings. It'll be like this, belongs to Z. This is the best and the easy way to write. Now anyone would read this would understand you're specifying range is from 0 to infinity, where all these numbers are belonging to integers only. So it can be whole numbers. It can't be a decimal point. So that's the thing. So that's basically it for this lesson. I hope you have found it helpful. If you have any doubts, please do post them in the charts, and I will get back to you soon with the next video. Until then, stay tuned, take care, and bye bye for now.